we shall continue our study of C programming language, and in the previous lecture we have just seen how to write simple programs to print variables, read variables, write assignment statements, and we have also seen the if then else construct. And we shall next see the for loop, the looping statement, and for this we will solve the example which I took in the first class, finding out the maximum of n numbers. So the example that we will take here is to find the maximum of n numbers. Now I have outlined the scheme for finding out the maximum of n numbers also. You first read in the number of numbers that you want, and then you read the first number, assign it to max, and then in a loop you read each number and update max if the new number is greater than the current maximum. And that is what we translate exactly into a C program in the next example. So let's go and see the example. As previously, we have got include stdio.h, the main program, and this is what the main program ends. We have declared a variable n which will read in the number of numbers, a variable max which will store the current maximum, and number which is a variable which will, each and every number will be read into this variable. I will be the loop control statement. So the first statement will be scanf and n. So we will read in the total number of numbers which are to be read in. If n is greater than 0, if n is not greater than 0, then obviously we don't have anything to do. So this statement is just there. Then we read in the first number here, and we assign max equal to number in the next line. And then here comes the for statement. The syntax is for, and there are three parts. First, this is the first part separated by a semicolon, this is the second part separated by a semicolon, and this is the third part. The first part is called initialization. Here I have initialized I equal to 1. Here I have done I less than n. This is the conditional. As long as this condition holds, the loop will continue. When this condition is not satisfied, it will go out of the loop. And I plus plus, it just does I equal to I plus 1. There are other issues related to this I plus plus which we shall come to later on, but for the time being it just does I equal to I plus 1. You could have written I equal to I plus 1 here also. I have just written I plus to introduce this construct. And this for loop, since there are more than one statements, you have to define it in a block. So the block starts here and ends here. This is the block which has got two statements inside. One is to read in the new number, and the other is the if statement. If number is greater than max, then max is assigned number. So this was the program, the algorithm which we discussed in the previous day to find out the maximum of n numbers, and this is the conversion to the program, and this is where the for loop ends, at this block, and then you print max equal to %d. Now we are supposed to read in total of n numbers. Now let us check whether we are reading in n numbers. We are reading in one number here, and this loop starts with I equal to 1 and continues as long as I is less than n. So it will read n minus 1 numbers in this loop. It will read n minus 1 numbers in this loop. So you can read exactly total of n numbers. So any questions about this program? Then let's, if there are no questions, then let us see how to run it. Let's run it and see. So the first input that you have to give is the number of numbers. I did not write the printf statements. Normally good programming means that you should write the printf statements, but since I wanted the program, whole program to come on one screen, I removed them. So let us read in 7 numbers, 3, 1, 5, 7, 0, -9 and say 12. The maximum is 12. Let us run it again, say 6 numbers, the maximum is 18. So this is how we compute the maximum, and this is how we use the for loop. So let's go back to the for loop. So this is the for loop. This is the for loop, and we could have even written from I equal to 2 till I is less than, sorry, from I equal to 2 till I is less than or equal to n. Still then we will read in n minus 1 numbers inside this loop. So you must write the loop in such a way that it takes care of this, the conditions are taken care of. You can write more than one condition here. You could have written I equal to 1 if you have got 2 or 3 variables to initialize. You could have written I equal to 1 and you could have written comma j equal to 0. But the whole initialization must end with a semicolon, and all the statements inside the initialization will go with commas. Similarly, here you can give multiple conditions, but they must be put in one statement like and, or, not. And here again you can give more than one statements which will do the loop update. In fact, here you could have even read in a number. You could have written functions also in the initialization like scanf, etc. But I don't want to go into complex issues here. So even if we do this I equal to 2, I less than equal to n, we still work correctly. So the max is 2. So we just, if you give in one more number, it does not matter, or it would have been better to see it the other way around. It will just read in the necessary numbers, the rest is just not read. So this is a program to find out the maximum of n numbers. So here we have seen how to use the for loop, and we have seen that the for loop consists of 3 parts separated by semicolons. This is the initialization, this is the condition. If this condition is true, only then it will go into the loop, and this is the loop update, that is what are the actions that will take place at the end of the loop. And you have to explicitly update it, unlike Fortran where you can write do I equal to 1, 10, 2, things like that. Automatic update of the variables does not take place. You have to explicitly update the variables in a for statement. There are other looping constructs like do and while, and we will not explicitly go through them, and we will visit them as and when we come through examples. So after having done the loop construct, we will see how to use arrays. Arrays are vital for any programming, because whenever you have to read in a block of data and you have to use it, you must require arrays. And one of the classical examples of using arrays is sorting. So we will take up an example of sorting, a simple exchange sort, and see how we will use arrays. All of us must have written this program before, and the basic algorithm which has been used is read n, then read n numbers into an array and then we use two loops to do the sorting, and the whole idea behind the sorting program is in each loop you are finding out the maximum element and storing it in the top position. So we use two loops and in the inner loop we do a comparison and an exchange. This is the idea of sorting. For example, we will do for I equal to 1 till I is less than n, I plus plus. When I is equal to 1, we will find out the maximum and store the maximum in the array location A1. So let the array be called data. Let the array be called data. Then when I is equal to 1, we will store the maximum in data 1. When I is equal to 2, we will store the second maximum in data 2, that is the maximum from in the rest of the array. So we will use a loop for j is equal to I plus 1 till j is say less than or equal to n, and increment it, and we will compare if data I is greater than, if data I is less than data j, then we will exchange data I and data j. This is one of the traditional sorting routines. There are other sorting routines like bubble sort, etc. They have a similar but slightly different way of doing it. So this is one sorting routine, and we shall see the how to write out this sorting routine. The main intention in this program is not how sorting is done, because we shall see how sorting is done in a much more better way in subsequent classes, but the intention here is to just translate a known program which contains an array declaration and some for loops into C language syntax. So let us see how the program looks like in our C language. So we include the stdio.h. We have just one main program which goes like this, from here to here. Now this is where we have declared the data array data. So int data 100. This means that data is an array of size 100 and it is an array of integers. The type is integer. I, j, n and temp, these are the variables which are declared. The first thing I do is read in the number of numbers, and then in a loop I read in all the elements of the array. And interestingly, I have read in from 0 to n minus 1. Though we saw in the just a minute ago that we were working from 1 to n, in C language when you declare an array, it starts from 0. So if you declare an array data 100, it starts from data 0 to data 99, not from data 1 to data 100. So these 100 locations start from 0 to 99 rather than 1 to 100. So you can utilize the 0th location. So that is what I did here. For I equal to 0, I less than n, I plus plus, and since this is a single statement, I did not require to put it in braces, because this statement is the only statement in the loop. so I did not require to put the brackets, but if you put the brackets also it's okay. You will put one bracket here and the closing bracket after this. So scanf, I read in integers and data I. I pass the address of the location data I. And then here is the for loop. We had previously discussed I equal to 1 to I less than n. Since we are going from 0, we will say I equal to 0 to I less than n minus 1, I plus plus. J equal to I plus 1 to j less than n, j plus plus. If data I is greater than data j, then we exchange it. So this one actually does finding the minimum. If we want to find the maximum, we will have to change this to negate, less than. So if data I is less than data j, we exchange, and we use these three statements to exchange. We use the temporary variable, assign it to data I is assigned to data j, and data j is assigned to temp. And this is the loop. Note that this for this for statement we did not require opening braces and closing braces, because this for statement has only one statement for it, and that is this for statement. So we did not require an opening bracket here and a closing bracket here after this, because this for statement has only one statement, which is another for statement, and this for statement has an if statement, has a statement which is only one statement, which is an if statement, and this statement has got a set of blocks. So it is just sufficient to put brackets here, though if you put brackets here as well as here you would have been safe, but it is not necessary. And finally we printed out the sorted array, I equal to 0, I less than n, I plus plus, printf. And then at the end of, after printing all of them, I printed a new line, and this terminates the C program. So is any questions on the program? So then let's run it. The first thing you have to give is the number of numbers, say 6, and then all of them. So it prints the sorted array 9, 4, 3, 2, 1, 1. Seven numbers. So this is how it gets printed. So this is the program for sorting, and this if I want to print all the numbers one after another, then I would have to give a backslash n out here. If I give a backslash n out here, then the numbers would come in all different lines. For example, if I give a backslash n out here, so I have given a backslash n here. So when I print the numbers, they are all supposed to come in different lines. So this is how you can use the controls to separate out. We shall come back to this program and study it later to understand two things. We will come to a variant problem, and we will see how we can solve that problem better, and we will see whether sorting is to be done this way at all or not, whether there is a better way to do sorting, and we shall go back to our old steps of initial problem definition refinement and generation of final solution to see whether we can get a better program for sorting, and why this is not the best program for sorting. So we shall come back to them later on, because it is our intention here to just go through arrays and functions. The next example that we will take is that of a multidimensional array. We will see how to declare a 2D array and how to do matrix multiplication. So this is an example of matrix multiplication, where we will do multiplication of two arrays of integers. Now here a 10 by 10 array of integers is declared like this: a 10 10. What is the advantage of doing it this way? I will come and explain a bit later on. B 10 10, C 10 10. We shall go deeper into why such things are there, to appreciate why C language has changed the constructs. Instead of writing a 10 comma 10, why have they done it this way? What does it mean? What does all this signify? We shall come back when we got used to more of C programming. So we have declared some integers. We read in the data. So we first read in the 3 dimensions, because we have to read in 2 arrays. One is an m by n array and another is an n by o array. And finally, if A is an m cross n array and B is an n cross o array, then C will be an m cross o array. So we read in the dimensions m, n and o, and after that we read in the data. Here we have read in the array A in a double loop, I equal to 1, I less than equal to m, but it would have been appropriate to actually do it from 0 to m minus 1, because somebody gives you 10 by 10, then you will end up in problems, because these arrays are always going to be declared from 0 to 9. Anyway, we will make sure that we do not give the data that way. So I equal to 1, I less than equal to m, I plus plus, j equal to 1. So we are reading it row wise, and again here and ai j, and you give it this way, ai j, not ai comma j, you give it this way. Again we read in the array B in exactly the similar way, except that the constructs are n and o, because we are reading in an n by o array. And this is where we perform the matrix multiplication. I do not want to go into details, because all of us possibly understand how to do matrix multiplication. There is an outer loop, I equal to 1 to m. Since m by n and n by o, so we will get an m by o array. So C array will, the loop in this here will be from I will be m and j will be o. And the first thing you do is initialize Cij to 0, and for k equal to 1 to n, we do Cij is equal to Cij plus Aik into Bkj. So this is standard matrix multiplication. This is just an example to use 2-dimensional arrays in C language. And here we print the result, and to print the result we have printed it in row wise format. I is equal to m, 1 to m, j is 1 to o, and after every row, see, this statement means from here, this means from here to here. So this is a block. This block contains one for statement, which is this. For I equal, actually this for statement actually goes like, you can write it in separate lines, but this is how it is. This is one for statement. For j equal to 1, j less than equal to j plus plus, you print this. And at the end of this whole loop, you print a new line. Even if you write it this way, it does not matter. The brackets actually take care of what your intention is. So now first we have to give the 3. So let's give a simple example where all of them are equal. Then you have to give the first one. So in order that we understand the result properly, let's give a simple example. So if we have given an array 2 matrices, all are ones, 2 by 2 matrices, obviously we are supposed to get back 2's. Let's give another example. I am sure you can make out that the results are correct, the inputs are given in that way. So now I have given a 2 by 3 and a 3 by 2, and I am expected to get a 2 by 2 back. So the first one, in order that we get the results, understand the results correctly, let us give 6 ones. In the next one, let us give another 6 2's. So obviously the program works correctly, and the intention was not to understand how matrix multiplication is done, but how to declare 2-dimensional arrays, how to put in for statements, and how to put in if, then, and for, a combination of if, then, and for in a 2-dimensional array. So that takes care of 2-dimensional arrays, and once we know what 2-dimensional arrays are, we can easily extend it to 3, 4, 5-dimensional arrays in a simple and a similar manner. But we shall come back to these examples to understand why we do it this way and what advantages these lead us to. We shall come back to these examples later on. The next, we come back to a very, very crucial concept. Functions, that is user defined functions. Now in any program, we have assumed that we know some programming language like Fortran or BASIC or Pascal, and in all of these languages you can use functions. So you will, in a program, say in a C program, you will have a main program, and maybe you will have an integer n, and maybe you will call a function, say xx, with argument n, and then do some other things and terminate, and you will declare a function xx with argument I, and then you will do something in this function. It may be a function, some people call it subroutine also, because you may not return a value. In C language, everything is a function, and you can return values through the arguments in a special kind of a way. Before we move into C language examples, let us clarify some terms. There are 2 parameters of a function. One is called the actual parameter, and this is called the formal parameter. Because this xx may be called many times with different actual value, actual arguments, and this is the formal parameter, wherever the function itself is declared. The type of the 2 must match. If the types do not match, there will be problems. Obviously you can have more than 1 parameters, and here also you must have the same number of parameters. You cannot have less or more, and their types should match in a 1-to-1 fashion. This is well known. So now let us see through an example what happens in a C program function. So let us take a very, very simple example. The first example will help us to understand the syntax of calling a C function, as well as the way a function behaves. So here I have got, now I have got a main program which ends here, and I have got a function called fun1 which ends here. And now what do I do in the main program? I do int a, b, c, then I read in 3 values, scanf and a and b and c, and in these 3 values before the call I print what the values are. I call the function like this, fun1 a, b, c. I can call it, I can do an assignment also, x equal to fun1, but we will see that later on. And then after the call I again print the value of the variables, and inside the function corresponding to a I have I, to b I have j, and to c I have k. And before the brackets open for the function I have to declare the type of the arguments. I can declare it here also inside the declaration, I can also declare it below. So I use the approach of declaring it below. We will see examples where we declare it there. So I have declared them to be integers, and inside the function I assign I equal to 21, j equal to 22 and k equal to 23. I need not put them in separate lines, just semicolon takes care, so that is fine. And I put in a print statement that inside fun1 I, j and k are these. Alright. So this is a very simple program. To understand what the syntax of a function definition is, the syntax is the first the function name, the arguments, then the type, and then the body, and the body again comes in brackets like this, just like a main program. And here I have just read in 3 values, and before the function is called I printed it, I called the function, inside the function I printed it after assigning it, and this is what I have done. If such an equivalent program was written in Fortran, then whatever I would have read would have been printed here. Inside the function they would have been converted to 21, 22, 23, and after the function call they would have been converted to 21, 22, 23. But that is not what will happen in C. So I will read in 3 values, 2, 3, 5. Now what do I get? I get before the call it is 2, 3, 5, that is what I have read in. Inside the function obviously after assigning it to 21, 22, 23, and after the call it is 2, 3, 5. So I did not get a change when I return back. That is, before the call whatever I read in I got, in the function these were reassigned, and after the function they were returned back. So why I did not get a change is the first question, and if I do not get a change, then what is the use of calling such a function, or how would I get a change if I want such a change, are the questions that we will have to answer. Because if a function does it requires some values and I may want some value to be updated, how would I do it? So to answer this question, first we will have to see how function parameters are passed in C, what are the ways in which function parameters can be passed, and how do I get back values in C if I want to pass the function parameters. That will also give us some hint about why scanf uses this AND. So let us go back to our workbook and see what we can do. So we have got the actual parameter here and the formal parameter here. Now in any programming language we shall see that when there is a function called, say, fun1 a, b, c, there is a call, and we have got the actual formal parameters as I mentioned before, I, j and k. Now these A, B and C are occupying some locations in the memory. So schematically let us say A, B and C. Now when this function is called, a new data segment for this function is set up. The variables, the arguments as well as the local variables of this function are allocated certain amount of memory, of which other than the local variables I, j and k are also allocated some memory locations. In C language this is what exactly happens. When a function is called, this memory is allocated, the value of A is copied into the value of I, the value of B is copied into the value of j, the value of C is copied into the value of k, and then this starts executing. After the execution is over, this memory is deallocated and the values are not copied back. This is how C programming works. This is called call by value. This is called parameter passing using call by value. C uses call by value. So they are copied into the local variables and the function is executed, and after the function is over these are deallocated. We shall see how this allocation and deallocation and memory access is done a little later on in more involved examples. In other programming languages there are slight variations. There is a variation called call by value result. What this does is, when the function is called, it copies the parameters, arguments, executes this function, and after the execution, before deallocation, it copies it back, copies the new values back. So that is called call by value result. And the other one which is used in Fortran is called call by reference. What happens here is, instead of these values, these locations are not in here, these are not actual locations, but these contain addresses to this location. And whatever you do here, whenever you update I here, this address is taken and this value is modified. The modification is done on the content of this address here. Alright, so if you write I equal to 5, then here there is a change. It uses this location to keep the address of A, it uses this location to keep the address of B, and it uses this location to keep the address of C, and it uses this address to modify the contents. So it does a star I operation whenever an I operation is given. So if you want to change something in I in the function here, it uses the content of this, it modifies the content of the address, which is something called indirect addressing, but this is what is called call by reference. There are other ways of parameter passing like call by name and others, but we will now concentrate on call by value, call by value result and call by reference, and C language uses call by value. So C language uses call by value and not call by value result or call by reference. Anyone who knows Pascal will know that in Pascal you can define this parameters in another way. If you write fun1 var I, then this means that this will be used as call by reference. If you write simple j, it means call by value, and again if you write say var k, then it will mean call by reference. So in Pascal, if you had written var I, j and k and done this, then this would not have changed, but this and this would have changed. Whereas in C everything is uniform, call by value. So we will have to see next how we make it call by reference. To make it call by reference, what we do is we pass the address location and modify the contents. Alright, so let us see in this example how we will convert it to call by value. So here what we did was we read in A, B and C, this is the value of A, B and C, and we passed in the to FunToo, we have used another function called FunToo, we have passed the address A and B and C, and printed the values after the variables. And in FunToo we declared I, j and k, but we now have to declare these as address locations rather than variables. So this is how we declare it: int star I comma star j comma star k. To understand what this means, a very simple logic has to be applied. What does star I mean? Star I means the content of I. So it says that the content of I is an integer. This means the content of j is an integer, and this means that the content of k is an integer. Understanding it this way will take us one step ahead in understanding all declarations in C. There are a lot of intriguing issues for declarations in C. We shall see them slowly, but here what we have done is we have done this, and we have done star I equal to 21, star j equal to 22, star k equal to 23. We have printed the values of star I, star j and star k and come out. Now let us see what should happen. Let us go back and just work it out first, and then we will see. So we had a call now FunToo A, where we passed AND A, AND B and C, and here we had FunToo I, j, k. So the three locations which will be copied here into I, here I will have the address of A in I, here I will have address of B, and here I will have address of C. So this address of A which is here will be copied in, address of B will be copied in here, and address of C will be copied in here. These are the parameters. What is the value of AND A? AND A means the address of B. So once this is copied in here, it does not matter whether it is copied back or not. What I am going to do is I am going to modify the contents inside. So those contents are going to change anyway, and I am going to get it back reflected. So that's exactly, so we'll just quickly see the program. So what I've done is I've passed the addresses A, B, C, changed the contents, and so now if we run it, So now before the call it is 1, 2, 3 inside the function, and now I have, though it's called by value, I have made sure that after the call I get back the correct values. And now you will appreciate why in scanf you have to pass the addresses, because it's called by value. If you had passed A, B and C, whatever you read inside wouldn't have been reflected back when you returned. So that is why you pass the addresses, and the scanf function actually modifies the contents. So whenever we want to get values back and passed back, we will have to use the contents and the address locations in C. This is a typical C style of programming. It is unlike in other languages like Pascal, where it is slightly different. In Fortran it's pure call by reference. In C it's call by value, and if you want reference calling you have to do it this way. So we'll stop here today, and we'll see more details of how to do function parameter passing and other things in the next day. Thank you.